Hello students, in this video we are discussing about physics exam revision for grade 9 advanced. In that, first question is about significant figures. Identify the significant digits in a given number. How to identify significant digits in any given number? In any given number, all non-zero digits are always significant. That is, our digits starting from 1 to 9, that is 1, 2, 3, 4 up to 9. All these digits are always significant in any given number. So the question is whether 0 is significant or not. In some cases, some situations, zeros are significant. In some situations, zeros are not significant. So we need to check when the 0 is significant and when zeros are not significant. So here, number 1, in a whole number, ending zeros are not significant. Whole number means number without a decimal. For example, if I write 500, this is a whole number, and if I write like 5.00, this is a decimal number because here there is decimal in that number. So in a whole number, ending zeros are not significant, which means all other digits are significant. So these are ending zeros, cancel these ending zeros. So how many significant digits here? Here only one significant digits. Then I will write another number. For example, 330. In this given digits, this is a whole number. In any whole number, ending zeros are not significant. So here this is ending zero, that is not significant. All other digits are significant. So how many digits here? 1, 2, 3, 4. 4 significant figures. Any number, if you take like 1115, how many significant figures? There is no zeros, no ending zeros. So all digits are significant. 1, 2, 3, 4, 5. So here we have 5 significant figures. Then if I write a number 220, okay, so in this ending zeros, in this whole number, ending zeros are not significant, so cancel these ending zeros, don't count these ending zeros. So 1, 2, 3, 4, how many significant digits? 4 significant digits. Okay, so that is one rule. In a whole number, ending zeros are not significant. Now we will go to the decimal numbers. In decimal numbers, how to find the number of significant digits in a given decimal number. Number 2, if a decimal number in a decimal number, that decimal number is equal to 1 or greater than 1. The decimal number is equal to 1 or greater than 1. All digits are significant. Okay, equal to 1 or greater than 1. All digits including zeros. Okay, all digits including zeros. All digits are significant. For example, we have a decimal number like 1.000. So in this number, this number is equal to 1, right? 1.000, it is a decimal number. Why? Because there is a decimal in this number. This point is called decimal. In a decimal number, if it is equal to 1 or greater than 1, then all digits including zeros are significant. So here how many significant figures? 1, 2, 3, 4. 4 significant figures. Why? In a decimal number, if it is equal to 1 or greater than 1. In this example, 1.000, that is equal to 1. So all digits including zeros are significant. Another number, for example 5.0010. This is a decimal number because there is a decimal here, and this number is greater than 1. All digits are significant. So how many significant figures here? 1, 2, 3, 4, 5. 5 significant figures. So if I write 1.2100, this number is a decimal number that is greater than 1. So all digits are significant. So tell how many significant figures? Tell. 1, 2, 3, 4, 5. 5 significant figures. Okay. Then the third situation, number 3. So we have to remember only 3 rules. Okay. So rule number 3, in a decimal number that is less than 1, in that case starting zeros are not significant. In a decimal number less than 1, then starting zeros are not significant. For example, I will give you a decimal number 0.1000. In this, starting zeros are not significant. All other digits are significant including zeros. So here there is no starting zero. So 1, 2, 3, 4. Number of significant figure is 4. Then if I write 0.0012, how many significant figures? Starting zeros are not significant. All other digits are significant. So starting zeros, these are the starting zeros. They are not significant. So how many significant figures? 1, 2. So we have 2 significant figures in this. Another one, for example 0.00100. How many significant digits here? Number of significant digits. Starting zeros are not significant. All other digits are significant. So 1, 2, 3. So these are the 3 rules to identify number of significant digits in any given number. Number 1, in a whole number, ending zeros are not significant. All other digits are significant. Number 2, if it is a decimal number that is equal to 1 or greater than 1, all digits including zeros are significant. Number 3, if it is a decimal number less than 1, starting zeros are not significant. All other digits are significant. And remember, in any given number, always all non-zero digits are always significant. In the EOT, the example given is question number 8 of page number 13 in the textbook. So here we have 10.8 gram minus 8.264 grams. So here we need to subtract. Here also we need to subtract. When you subtract or add during addition and subtraction, how to write the answer in correct number of significant figures? In subtraction and addition, you need to write the answer in least number of decimal places. You need to remember this rule. Write the answer in least number of decimal places when you do addition or subtraction. For example, 10.8 gram, how many decimal place here? Decimal place means number of digit after the decimal. So how many digits are there after this decimal? So here you can see after the decimal there is 8, means there is only 1 digit. So how many decimal place here? Number of decimal places 1. In this number 8.264, how many decimal place? After the decimal you can see there are 3 digits, 2, 6, 4. So how many decimal places? 3. Then you compare this 3 and 1, means compare the number of decimal places in each number given, means each term in this calculation given. So compare 3 and 1. When you compare 3 and 1, you know that 1 is smaller than 3. 1 is the smallest number of decimal place in this. Then you need to write the answer in only one decimal place. For example, if I subtract this 10.8 minus 8.264, so I am getting 2.536. But if I write this answer, how many decimal place here? You can see there are how many digits after the decimal? After the decimal in this answer, you can see after the decimal there are 3 digits, 5, 3 and 6, 3 digits. But you should not write in 3 decimal places. When you write the answer should be written in least number of decimal places, smallest number of decimal places. So here smallest number of decimal place among these is 1. So round this to 1 decimal place. So your answer will be 2.5 gram. You need to write the answer, or you need to round your answer to 2.5 gram. The next one is 4.75 meter minus 0.4168. This also subtraction. During subtraction and addition, you need to write your answer in smallest number of decimal places, least number of decimal places. How many decimal places here? 2. Number of digits after the decimal 1, 2, 7 and 5, right? So 2 decimal places. Here after the decimal there are 4 digits, so number of decimal places 4. When you write the answer, you need to write your answer in 2 decimal place, because 2 is the smaller number here. 4.75 minus 0.4168, that is equal to, I am getting 4.3332, 4.3332 meter. But I should not write like that, because if I write this answer, here you can see there are 4 decimal places, but I need only 2 decimal places, so we need to round to 2 decimal places. 4.33 meter is the correct answer. Okay, you need to write your answer in that way. The next 2 examples given are multiplication and division. During multiplication and division, the rule is different. In addition and subtraction, you need to write your answer in smallest number of decimal place, but during multiplication and division, you need to write your answer in smallest number of significant figures. So how many significant figures in this example, like 139 centimeter multiplied 2.3. So here how many significant digits? 1, 2, 3. 3 significant digits. Here 2 significant digits. When you compare this, 2 is smaller. So when you write the answer, you must write the answer in 2 significant figures only. So 139 multiplied 2.3. I am getting 319.7 centimeter multiplied centimeter, so centimeter square. In 319.7, how many significant figures? How many? 4 significant figures, right? 4. But we should not write the answer in 4 significant figures. We should write only in 2 significant figures, because here in the question the smaller number of significant figure is 2. So I need to round this answer to 2 significant figures. So round this to the next digit, means next number of 2 significant figures. So it will be 320 centimeters square. Then in the next example, that is division. During the division, we need to write the answer in smallest number of significant figures, least number of significant figures. So here how many significant figures? 13.78 in this 4 significant figures, and here 3 significant figures. So we need to write our answer in 3 significant figures. 13.78 divided by 11.3, I am getting the answer 1.21946 like that. So 1.21946. So we need to round this answer, okay, and after this 9 also there. Yeah, we need to round this answer to two significant figures. When I round this, it will be 1.22, because I am not writing 1 here because the digit after 1 is 9. So round it to the next number, 1.22. And what is a unit? Gram per milliliter. Question number 2 is about base units, derived units, and scientific notations. So we will discuss prefixes also in this. What are base units? Units that can be defined by itself. So we have 7 base units. Base units. We have 7 base units. For example, unit of length. Length is meter. Meter we represent by the letter M. And the unit of mass is kilogram. That we represent by writing kg. Then unit of time is second. We represent by the small letter S. Then next is electric current. Its unit, electric current, is the unit of electric current is ampere, and we represent it by the letter A, capital letter A. After this, temperature. Unit of temperature is Kelvin. We represent by the letter K. And the next is amount of substance. Unit of amount of substance is mole, that we represent by MOL, mole. Then next is luminous intensity. Unit of luminous intensity is candela, that we represent by CD, capital letter C, small letter d. Then we have derived units also. Derived units means that can be expressed in terms of base units, means more than base units. For example, the SI unit of speed is meter per second. So here meter is a base unit, second is another base unit. Meter per second is a derived unit. Why? Because it is defined by two base units. So any unit that can be defined by more than one base unit, that is called derived units. For example, unit of force, that is equal to Newton. Unit of force is Newton, that is a derived unit, because Newton we can express as kilogram meter per second squared. Unit of acceleration, that is meter per second squared. Meter per second squared. So here you can see in the unit of force, that can be expressed as with the help of base units, right? Kilogram is a base unit, meter is a base unit, second is a base unit. So units that can be expressed in terms of base units are called derived units. Then here, why do we use unit? We use unit to represent our measurements. For example, if I measure this length of this whiteboard, this is 120 watt. Is it 120 kilometer, 120 meter? No, 120 centimeter. Centimeter is a unit. Why do we use unit? We use unit to represent our measurements. Sometimes the measurements will be very small, then we need small units. Sometimes the measurements will be very large, then we need larger units. To make the units smaller or larger, we use prefixes. If I measure the length of this room, the length of this room is about 4 meters. or 5 meters, we represent that in meter. Meter is the SI unit of length. But if I measure the length of this marker, it's about 10 centimeters. Now we are telling the length in centimeters, another unit. Why? Because now the measurement is smaller. The length of the marker is smaller compared to the length of the room. Means we are using smaller unit to represent smaller measurements. How to make the SI unit smaller? By using prefixes. We can make the SI unit smaller or larger by using prefixes. Now we will discuss about prefixes. First one is pico, anything. Pico represent 10 to the power minus 12, 10 to the power minus 12. Picometer, which means PM, picometer, which represent 10 to the power negative 12 meters. After this, nano that we represent by the letter small letter n. Okay, nano we represent by small letter n. Nano stands for 10 to the power negative 9. So I will write that here. Pico we represent by the letter P, nano we represent by the letter n. If I tell like nanosecond, which means 10 to the power minus 9 second. It's very small unit. Then after this we have micro. Micro we represent by this letter mu. It's a Greek letter, it looks different. Micro. Micro stands for 10 to the power negative 6. For example, micrometer, that is 10 to the power negative 6 meter. Then it is very familiar, milli. Milli stands for 10 to the power negative 3. For example, millimeter, millisecond, milligram, milliliter. Then after this we will like centi. Centi we represent by C, centi. Centi stands for 10 to the power negative 2, that is 1 by 100 of a meter is centimeter, right? So we represent centimeter. Okay, centimeter, centi stands for 10 to the power negative 2. Centimeter means 10 to the power negative 2 meters. After this we have deci, that we represent D by D, deci. Deci is 10 to the power negative 1. So decimeter means 10 to the power negative 1 meter. Then we will use another set of prefixes that we use to make the SI unit larger. For example, if you are representing, if you are measuring a larger distance, the distance from Abu Dhabi to Sharjah, so we represent that in a larger unit, for example, kilometer. So kilo, that we use the letter K, kilo. Now this side we are making the SI unit larger. Okay, by using prefixes, by adding prefixes, kilo stands for 10 to the power 3, right? 10 to the power 3, that is 1000. By adding prefixes before a unit, so meter is a unit. Before that, if I add a prefix kilometer, now the SI unit is becoming bigger. Kilometer means the unit is becoming bigger. Then this is also meter, this also meter. Before this meter, if I add C, C is a prefix, centi. Centi we used to mean centi stands for 10 to the power negative 2, right? So the unit becomes smaller, the size of the unit is reduced. Then kilo. Okay, after one is mega. Mega we represent by capital letter M, mega, that is 10 to the power 6. And after mega we have giga. Giga we represent by capital letter G, giga. Giga stands for 10 to the power 9. Then we have tera, T 10 to the power 12. It goes like this. Now we will discuss how to use these prefixes. Each prefix represents powers of 10. For example, kilo represents 10 to the power 3. So we will discuss how to use kilo. we have a distance for 5400 meters. So how to change this into kilometers? Whenever you add a prefix, for example 5400, the meter you are changing into kilometer if you want to change. So which means you are adding prefix, right? Whenever you add a prefix, you need to divide by the power of 10 the prefix stands for. Here k represent 10 to the power 3. So you need to divide because you are adding prefix here. Whenever you add a prefix, divide by 10 to the power 3. Means you are dividing by 1000. 5400 divided by 1000, it will be 5.4. So your answer will be 5.4 kilometers. So that is how you are going to use prefix in any situation. When you add a prefix, then divide the number by the power of 10 the prefix stand for. Okay, then for example, how to remove a prefix. For example, you have a number 4800 millisecond. Okay, 4800 millisecond. So this milli represent 10 to the power negative 3, and you want to remove that prefix. Okay, you want to remove it. When you want to remove it, for example 4600, if you want to remove this milli from here, when you remove, then you multiply by the power of 10. When you add a prefix, divide by the power of 10 the prefix stand for. And when you remove a prefix, multiply by power of 10. So this milli represent 10 to the power negative 3. So multiply by 10 to the power negative 3 second. So when I change this, it become 1 2 3. It's like a 4.8 second. 4800 millisecond, that is equal to 4.8 second. Now we will discuss question number 3. The question number 3 is identify the equation for linear graph, quadratic graph and inverse graph. So what's the equation for linear graph? What is linear graph? This is the x-axis and y-axis. A linear graph represents the relationship is a straight line. So linear graph is a straight line graph. I will draw like this. This represents a linear graph. In this linear graph, this is the y-intercept, and you can calculate the slope also. For a linear graph, slope will be constant. So what is the equation? Equation for linear graph is y equal to mx plus b. The relationship between y and x is y equal to mx plus b. In this, y is the variable on the y-axis, m represent slope. In this equation, m is the slope. How to calculate slope? Delta y divided by delta x, right? That is y2 minus y1 over x2 minus x1. That will be coming in another question, how to calculate slope. I'm just discussing here. So what is x? Variable on the x-axis. And what is b in this equation? B is the y-intercept. That is the point on the y-axis where the graph touches the y-axis. Okay, so that is the equation for the linear graph. The next we will draw the quadratic graph. This is the y-axis and this is the x-axis. Quadratic graph will be something like this. So what is the equation for quadratic graph? Y equal to ax squared plus bx plus c. So here what is a, what is b? They are constants, and y is variable on the y-axis, x is the variable on the x-axis. Now we will discuss about the inverse graph. The shape of the inverse graph will be something like this. Inverse graph. So in the inverse graph, the relationship is y is equal to a divided by x. So here you will see in the first one, in the linear relationship, you can see in the linear graph y is proportional to x. The proportional I will just represent by this symbol. Y is proportional to x. In a linear relationship, y variable is directly proportional to the x variable on the x-axis, and in a quadratic relationship, y is directly proportional to the square of x squared, that you can see in this equation. Y is equal to ax squared. And in the inverse relationship, y is directly proportional to the 1 over x. Here x is in the denominator. What does it mean? It means when x increase, the value of y will decrease. Question number 4. To define and calculate average acceleration. Basic question, right? Means basic concept. To define and calculate average acceleration. What is acceleration? Acceleration is rate of change of velocity. What is acceleration? Rate of change of velocity. If the velocity of an object is changing, which means the object is accelerating. If the velocity is increasing, acceleration is positive, and if the velocity is decreasing, then acceleration is negative. Acceleration is a vector quantity, so it can be positive and negative. It's an example for vector quantity. So just acceleration is a vector quantity, and the unit of acceleration is meter per second squared. What is the equation to calculate acceleration? Acceleration, that is rate of change of velocity, which means acceleration is equal to change in velocity divided by time. What is change in velocity? Change in any quantity is final minus initial. Change in velocity is velocity final minus velocity initial divided by the time taken, delta t. So delta t just represent time taken, the time duration, okay, time interval, the time taken to change the velocity from initial to its final value. Now we will solve some questions. I am not writing the question on the board. So this question is from the question number 789 from the page number 63 of your textbook. Question number 7. A bus is moving west. So we have the direction like this, right? This is the origin, north, south, west, east. West, east, V. So just write V, okay? West and east. So it's moving towards the west. Moving towards the west means it is moving to the left side. If an object is moving to the left side, its velocity is taken as negative. So west side is negative. So a bus is moving west. So its initial velocity initial, that is negative 25 meter per second. Bus is moving west at 25 meter per second. When the driver steps on the brake and it brings the bus to a stop. When the bus stops, velocity final is 0. When it stops, its velocity becomes 0. So final velocity is 0. And what is the time taken? The time taken for that change of velocity is 3 seconds. That is given in the question. Okay, I'm just reading the question and writing what's given in the question. And question A, you need to calculate what is the average acceleration of the bus. You need to calculate the average acceleration. The equation to calculate average acceleration is velocity final minus velocity initial divided by t. So velocity final is 0 minus velocity initial is minus 25 divided by time is 0. Minus minus become plus, so 25 divided by 3. 25 divided by 3, how much? 25 divided by 3 are 8.33. So 8.33 meter per second squared is the value of the acceleration, value of the average acceleration. That is how you need to calculate the value of average acceleration. In the question B, in that, okay, this is like section B of this question. B. If the bus took twice the time means before it took 3 seconds, now it's taking 6 seconds to stop. So what will be the answer? The answer will be like this, right? Acceleration is equal to, instead of everything else is same, so 0 minus 25 divided by 6. So it becomes half of this value, right? 8.25 divided by 6. How much? 4.15, right? 25 divided by 6, that is 4.17. 4.17 meter per second squared is the unit of acceleration. In that next question, question number 8, a car is coasting backward downhill at a speed of 3 meter per second when the driver gets the engine started. After 25 seconds, the car is moving uphill at 4.5 meter per second velocity. If the uphill is chosen as positive direction, what is the average acceleration of the car? So what is the velocity initial? Velocity initial, the car is coasting backward downhill at a speed of 3.0 meter per second, and downhill is taken as negative, so negative 3.0 meter per second is the velocity initial. And what is velocity final? Velocity final, that is after 2.5 seconds the car is moving uphill at a 4.5 meter per second, 4.5 meter per second, and the time taken delta t, that is equal to 2.5 seconds. Here uphill is taken as positive, that is why velocity final is positive 4.5, and we need to calculate the acceleration. So here acceleration, that is equal to, velocity final minus velocity initial divided by time. Velocity final is 4.5 minus 3 divided by time taken is 2.5, that is equal to 4.5, it will be 3, right? 4.5 minus, so 7.5 divided by 2.5, that is equal to 3 meter per second squared. That's the answer for that question. Then next is question number 9. Question number 9 from the textbook. Okay, so now we are discussing question number 4. Define and calculate acceleration from the revision. That revision Heikel, right? You call Heikel. Okay, yeah, that one. So in that acceleration we are discussing question number 7, 8 and 9 from the page number what? Page number 63. Okay. So now we already discussed question number 7, question number 8. Now we are discussing question number 9. So question 9, Sultan has been jogging east towards the bus stop at 3.5 meter per second. So Sultan's velocity initial 3.5 meter per second. Okay, whenever you read the question, you write like this, what is given in the question. So it will be easy to solve any questions, any problems in physics. So this is the easiest way, okay, to solve any question. Whenever you read the question, write what is given in the question. Sultan has been jogging east towards the bus stop at 3.5 meter per second. When he look at his watch and sees that he has plenty of time before the bus arrive, over the next 10 seconds he slows down his pace to 0.75 meter per second. So his final speed is how much? 0.75 meter per second. In what time he is reducing his speed? He is reducing his speed during a time of 10 seconds. You need to calculate what? Calculate the what is his average acceleration. So acceleration, that is velocity final, that is here 0.75 minus velocity initial divided by time taken is 10. 0.75 minus 3.5 divided by 10. I will use the calculator to do the calculation. 0.75 minus 3.5 divided by 10. So I am getting 0.275 meter per second squared negative. Okay, I am getting negative answer. Why negative answer? For acceleration, because he is slowing down. If the speed is decreasing, acceleration will be negative, and if the speed is increasing, acceleration will be positive. But if he is traveling in the negative direction, it will be opposite. Question number 5. To find the slope and y-intercept of a position time graph and analyze the motion of the object using position time graph. So first we will draw a position time graph. Whenever you draw a position time graph, position on the y-axis, position here in meters, and time on the x-axis in seconds. So I will just tell how to calculate the slope of different position time graph and how to find the y-intercept. So here I am drawing a straight line graph. So this is the time axis. For example, it is 1, 2, 3, 4, 5, like this it will go. Here y-intercept means this graph is touching y-axis. Where it is touching y-axis? It is touching the y-axis here. That point, that value is the y-intercept. For example, this is like 0, 5, 10, 15, like that. So what's the value of the y-intercept of this graph? 5, right? 5 is the value of the y-intercept. This graph is a straight line. Every straight line has a constant slope. If the graph is a straight line, its slope will be constant. What is the meaning of constant slope? At any point, if you calculate the slope, you will get the same answer. That is called, it has constant slope. So we will take 2 points. Okay, we will take this point here. Any 2 points we will take to calculate slope. You can take the first point here also. Anywhere on the line you take 2 points. What is the first point and what is the second point? First point, that we need to check from the x-axis. Whatever that happens first, that is the first point, number 1 here. For example, this is happening here about just after 1 second. So this is our first point, and this is happening after the 5 seconds, right? So this is our second point. So what point is happening at first in the time? That is the first point, and what happening later, that is the second point, that you need to check from the x-axis. Okay, whatever comes first on the x-axis, like here, that is the first point, and whatever happens after some time, that is the second point. Yeah. Now the slope equation. What is the equation to calculate the slope? You know that, right? Equation to calculate slope is y2 minus y1 over x2 minus x1. First you need to know the value of y2. How to find the value of y2? From here, go to the, from the second point, go to the y-axis. So for example, it is 20. So just write 20 minus. Then you need the value of y1. How to find the value of y1? From the first point, go to the y-axis. So it is between 5 and 10. I will write 8. 20 minus 8 divided by. Then what you need? You need x2. From the second point, this is the second point, go to the x-axis. So I am getting about 6. I will write a 6 here, minus. Now I need x1. From the first point, go to the x-axis. I am getting about 1, maybe like 1.2. Let me write 1 for make the calculation easier. So I will just write 1. Okay, it's about 1.2. 1.2 I will write, otherwise you will think that in the exam also you will do that. Okay, so 10, 20 minus 8, that is 12 divided by 6 minus 1, so minus 1.2, so it is 4.8. When you do the calculation, you will get the answer for the slope. Okay. Now I will give another graph and we will calculate the slope of that. We are continuing, okay, continuing question number 5, not another question, okay, same question. So we are discussing another type of graph here. This is the position time graph, okay, position, and this is the time axis. Like in the last graph it was like this. What is the meaning of this graph? You can see here when time is increasing, like 1, 2, 3, 4, 5. So here we started like this, right? 5, 10, 15, 20, 25, like that. When time is 0 means here position is 0, this one. When time is 0, what was the position of the object? The object was at 5 meter away from the origin. This is the origin. After 1 second, it is about 8 meter away from the origin. After 2 seconds, it is about 13 meter away from the origin, which means now this object is moving away from the origin because its distance from the origin is increasing with time. So this graph represents the object is moving away from the origin. Now we are drawing another type of graph. This graph, so it's starting from here. What does this graph represent? When time was 0, means at the starting, what is the position of the object? 25 meter. The object is 25 meter away from the origin. After 1 second, it is 20 meter away from the origin. After 2 second here, it is about 12 meter away from the origin. After 3 second, it is about 5 meter away from the origin. After 4 second, it is reaching here, which means here it does not mean, like for example, you always think, yeah, it's going away, no. See, position you need to count, you need to read from the y-axis, okay. Y-axis is the position, y-axis is decreasing, right? So now what is happening? It is actually moving towards the origin. It is moving towards the origin. Some students, when they look at the graph, they think that, yeah, it is moving away. No. It's you need to read the position, okay, from the y-axis. You will see at 0, position is 25 meter away from the origin. So after 2 seconds, it is about 12 meter away from the origin. After 4 seconds, it is reaching the origin, which means this graph represents the object is moving towards the origin. Object is moving towards the origin. If an object is moving towards the origin, its velocity will be negative. If the object is moving towards the origin, velocity is negative. And what does slope of a position time graph represent? Slope of a position time graph, that is equal to velocity. If the object is moving towards the origin, its velocity will be negative. So the value of slope here will be negative. If the graph is like this, okay, it is like this going down, slope down, then the slope of the graph will be negative. So when you calculate the slope, you will get a negative value. So first we will check what is the y-intercept of this graph. Check to find y-intercept, check at what point the graph is touching y-axis. See, this graph is touching y-axis here. So what is the value of the y-intercept? 25 meter. 25 meter is the value of the y-intercept of this graph. Now you will calculate the slope. What is the equation to calculate slope? Everybody know that y2 minus y1 divided by x2 minus x1. We need to take 2 points on this graph to find the slope. First point that we will take first time. Second point, second time after some time. So for example here we will take 2 points, this one and this one. when you take this one, yeah, okay, yeah, okay, leave it. We will take 2 points. So when you see this, some students will think this is the point 1, this is point 2. That is not correct. Here point 1 is that you need to take from the x-axis, okay, from the time axis. Which one is happening first? See, this point happening when it is at 1 second, time is at 1 second. So this is the first point, okay. Many students take this is the first point and they get wrong answer. This point happens at 3 seconds, right? Compared to this one, this is happening about at 1 second, and after 2 seconds this point is occurring. So this is the second point, okay. Then what you need to calculate slope, you need y2. How to find y2? From the second point go to the y-axis. I am getting about 7.5. I will write 7.5, not exact value I am writing, okay. When you watch the video you may think that why 7.5, it must be only 6. It's not the exact value, okay. I am writing just about, okay, about that value I am writing. Then we need the value of y1. What's the value of y1? How to find? From the first point go to the y-axis, about 17 I will write, divided by, now we need x2. From the second point to go to the x-axis, I am getting about 3, minus we need x1. From the first point to go to the x-axis, we are getting 1. So 7.5 minus 17 divided by 3 minus 1. What is 3 minus 1? 3 minus 1 is 2, right? So it will be negative, right? Because 17 is greater than 7.5. So 7.5 minus 17 divided by 2, I am getting negative 4.75. Negative 4.75. It will be meter per second. Why meter per second? Slope of position time graph, that is equal to velocity. Unit of velocity is meter per second. Here position in meter, right? Position in meter, time in second. So position y by x, meter by second, meter per second. Okay, now we will discuss 2 more different graph, okay. How to find the slope and how to find the y-intercept. Okay, now we will discuss these 2 graph also, how to find the slope and how to find the y-intercept. We will do it very fast, otherwise the video will be too lengthy. Then okay, this is x-axis, this is the y-axis. These are all minus values, right? Like negative 1, negative 2, negative 5 I will write, negative 10, negative 15. So negative 20 it will go like this. Okay, and the time will go like 1, 2, 3, 4 like that, etc. 1, 2, 3, 4 like that, and here negative values. So it will be like negative 5 I will write, negative 10, negative 15 like that. Just example, okay, only examples. So here students, what is a y-intercept? Here y-intercept is negative 5, and here the value of the y-intercept will be this one, okay, like this, okay, this whatever the value is there, that is equal to y-intercept. Then how to find the slope? Here we will take 2 points, okay, any 2 points we will take. So I will take this point here 1, and we will take 1 point here. So slope, that is equal to, slope is equal to y2 minus y1 over x2 minus x1. Here also slope is equal to y2 minus y1 over x2 minus x1. So how to find y2, which is our point number 1 here. Whatever happens first, this is point number 1 because it is happening at 1 second, and point number 2 this one. So what we need first, y2. From here go to the y-axis, negative 15 minus what we need next, we need y1. From the first point go to the y-axis. So we will get like a negative 15 minus this is about 7.5 minus, okay, minus 7.5 divided by x2 minus x1. X2 will be, because it is time, right? Time will be always positive, okay. So x2 from the second point go to the x-axis 3, minus from the first point to go to the x-axis 1, like that, okay. When you calculate you will get the answer. Then here also y2 minus y1. we will take 2 points here. Okay, so I will take first point here and the second point here we will take. So how to find the value of y2? So this is happening first, right? First point and second point. Whatever happens later, that is the second. Some student, okay, I'm not repeating that. Yeah. Now see here, to get the value of y2 from this point, go to the y-axis. From the second point, go to the y-axis. So you will get y2 value, and y1 value from the first point, go to the y-axis. Okay. Then so it is like -5 minus about first value is about 8, right? -8. Okay, divided by what is the value of x2 from the second point, go to the x-axis 2, x1 from the first point, go to the x-axis 1. When you calculate, you will get slope. I'm just explaining here how to calculate the slope. The next one is question number 6. It is interpret position time graph that represents the motion of a single object. Question number 22-23 of page number 42 of your textbook. In page number 42 of your textbook, question number 22-23. Okay, yeah. So in that, if it is a graph like a position time graph, position and time graph, so this is like position, different position 5, 10, 15 like that, and here it is like 1, 2, 3, 4 like that, and the graph is like this. So if they ask what is the distance traveled, between 1 second and 4 seconds, between 1 second and 4 seconds, at 1 second this is the position. So that is the initial position. We will write xi, initial position initial. Okay, then at 4 seconds, so here this is the second, like position final. Okay, final position. How to find the distance traveled, delta x, that is change in position. Change will be always final position minus initial position. So what is the value of final position? It's about 14. We will write 14 minus the initial position is 5. We will write 14 minus 5, that is 9 meter is the distance traveled. See, I am explaining how to calculate the distance traveled from a position time graph. This graph is not same as given in your textbook. So answer will be different, okay, from the answer given in the textbook. Here in this question, I am explaining how to calculate the distance traveled from a position time graph. I am not using the same question. I am not using the same graph that is given in the textbook. Okay, no, don't get confused. That's why I'm explaining in this way. Students, now we are discussing question number 7 of your exam revision. Question number 7 from equations of motion, one of the most beautiful concept of physics, using equations of motion to solve the numerical problem. So here we will be discussing question number 16, 17 and 18 from page number 67 of your textbooks. Okay, so I will start with question number 16. Whenever you use equation of motion to solve numerical problems, there are 5 ingredients. So first you need to know what are the 5 ingredients. First one is initial velocity, final velocity, acceleration, displacement, time. These are the 5 ingredients that you need to solve numerical problems using equations of motion. First question, a golf ball rolls up a hill towards a miniature golf hall. Assume the direction towards the hall is positive if the golf ball starts with a speed of 2 meters per second. When you read the question, you need to find the ingredients. Okay, so you need to write what is given in the question. Initial velocity is 2 meters per second. Initial velocity 2 meters per second. It is given when it is going towards the hall. Take it as positive, that direction, and slows at a constant rate of 0.50 meter per second squared. If anything is given in a unit like 0.5 meter per second squared, what is that? Is it time? Is it final velocity? If it is given in meter per second squared, that will be, or that must be, acceleration, because meter per second squared is unit of acceleration. So only acceleration will be given in that unit. So acceleration is given as 0.5 meter per second squared. What is its velocity after 2 seconds? After 2 seconds, time is given. Time is given 2 seconds. What is its velocity after 2 seconds? So it is the final velocity. You need to calculate final velocity. Then what about displacement? Displacement here, displacement is not given. Displacement is not given. Whenever you solve numerical problems using equations of motion, you have 3 equations. So the main thing is, the main idea is, you need to know which equation that you need to use to solve that question. How to identify which equation that you need to use. I will give you a tip for that. So we have 3 equations. Okay, 3 equations. Equation number 1 is, using different color will be good, right? So now using black color. So equation number 1 is final velocity, velocity final, that is velocity initial plus acceleration multiplied time. This is the number 1 equation. Number 2 equation, displacement, that is equal to initial velocity into time plus half multiplied acceleration multiplied time squared. And equation number 3 is final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta x. So these are the 3 equations. Which equation will you use to answer this question? For that we have an idea. So you can use the first equation if delta x, that is displacement, not given in the question. Because in this equation, you can see in this equation delta x is not there. So if delta x is not given in the question, you can use that equation. What is out of these 5 ingredients, which one is not there in this equation? Which one? We have final velocity. Final velocity not there in this equation. So if final velocity is not given in the question, then you can use this equation, equation number 2. That is how you need to identify, okay, which equation that you need to use. What is missing in this equation? In that equation, out of these 5 ingredients, final will 1, 2, 3, 4 are there. 1 will be missing. What is missing? What? Time. Correct. Time is missing. So if time is not there, then you can use equation number 3. So in this equation, delta x is not given. Delta x is not there in the question. So we can use the first equation. First equation is final velocity, that is velocity initial plus acceleration into time. What is the value of velocity initial? 2, right? 2 plus what is the value of acceleration? 0.5 into time is 2. So 2 plus 0.5, there is one more thing. It is slowing down. The ball is slowing down, right? That I forgot. If it is slowing down, acceleration will be negative. If the velocity is decreasing, acceleration will be negative. Okay, so here this 0.5 is negative. So 2 plus 0.5 into 2, that will be negative 1. 2 plus negative 1, that will be 1. So 1 meter per second is the velocity of the ball, final velocity of the ball, or velocity of the ball after 2 seconds. This is how you need to use the equation of motion to solve questions. Now we will discuss the next question. Okay, question number 17. Okay, this equation we need. No need to erase that. velocity initial squared, right? Okay, so question numbers, in that we discussed only question A. Okay, question A we have done, section A we have done. Now section B. What is the golf ball's velocity if the constant acceleration continues for 6 seconds? If the constant acceleration, here acceleration is negative, right? If it continues for 6 seconds, then what will be the ball's velocity? See here, if the constant acceleration continues, what will be the final velocity of the ball? Final velocity we need to calculate just like this. Initial velocity was how much? Initial velocity was 2 meter per second. Final velocity we need to calculate. Acceleration was 0.5, and if it continues for 6 seconds, what is the value of the final velocity? So displacement is not given in this question. We will use the same equation to calculate the final velocity. We just have to change the value of time. So final velocity, that is equal to initial velocity plus acceleration into time. Initial velocity is 2 plus acceleration is negative 0.5 into time is 6. So it will be 2 plus negative 3, that is negative 1 meter per second. That will be the final velocity. And section C of the question, describe motion of the golf ball in words and with a motion diagram. Okay, now we will go to the next question. Okay, question number 17, because we are solving. Okay, we will discuss the how to solve the questions, because you have only the multiple choice question in your exam, right? You need to select the answer, you don't have to describe. So question number 17. A bus is traveling 3 km/h east, has a constant increase in speed of 1.5 meter per second squared. What is its velocity? 6.8 seconds later. A bus is traveling 30 km/h. 30 km/h, it is the initial velocity. We need to change that into meter per second, because here acceleration given in meter per second squared in the SI unit. So it has a constant acceleration, that is 1.5 meter per second squared. 1.5 meter per second squared is the value of the acceleration. What is its velocity? We need to calculate the final velocity. What is its velocity after 6.8 seconds later? 6.8 seconds later. And it is not given. Displacement is here not given. How much traveled? How far it is traveled, that's not given. So which equation will you use? I know you know the equation, right? If delta x is not given, you will be using the first equation. But here there is one thing you need to note. Here this initial velocity is given in km/h, that you need to change into meter per second. So if you change, like if you multiply 30 into 3.6, okay, 30 multiplied 3.6, it will change into meter per second, okay, 108. To change km/h to meter per second, you can do like this, okay, 30 just multiplied by 3.6, so km/h will change into meter per second. When you do that, you will get 108 meter per second. So that is the value of the initial velocity. You need to calculate final velocity, that is equal to initial velocity plus acceleration into time. What's the value of the initial velocity? Initial velocity is 108 plus here acceleration, it is slowing down or speeding up. A bus is traveling east, has a constant increase in speed. So acceleration is positive, right, because its speed is increasing. So I will write positive value 1.5 into time. Time is 6.8. Now we will do the calculation. 108, no need to do the calculation, right? You will do the calculation and write the answer. 108 plus 1.5 times 6.8, that is equal to 118.2 meter per second. 118.2 meter per second. That is the answer for this question number 17. Okay, now we will discuss question number 18. In question number 18, if a car accelerates from rest, starting from rest, so initial speed or initial velocity is 0. If a car accelerates from rest at a constant rate of, so no need to write these things, right? Here I have written everything, all the 5 ingredients you need to write here. Initial velocity 0, acceleration is rest at a constant rate 5.5 meter per second squared, that is acceleration 5.5 meter per second squared, that is the value of acceleration. How long will it take for the car to reach a velocity of 28 meter per second? So its final velocity is 28 meter per second and it is not given, displacement is not given. You need to calculate the time. If displacement is not given, again use the first equation. Okay, final velocity, that is equal to initial velocity plus acceleration into time. Final velocity, that is 28, equal to initial velocity 0 plus acceleration 5.5 into time t. T you need to calculate, rewrite the equation. Okay, rewrite the equation. So this equation for time becomes 28 divided by 5.5. Don't tell you don't know this, how to rewrite the equation. 28 divided by 5.5, that is 5.09. So I will just write 5.1 second. 5.1 second is the time taken for that. You got the answer, right? Question number 8 of your exam, that also from equations of motion, from page number 71 of your textbook. Okay, 71, page number 70 and 71. Okay, 70 and 71 of your textbook, and question number 8 of the revision, example 4 and 5. So first we will solve example 4. This also solving questions using equations of motion, same method you will be using. Okay, first you need to write the value of the ingredients given. In every question, one of them will not be given and one of them you will have to calculate. So 1, 2, 3, 3 will be given, 1 you will have to calculate, 1 will not be given. From that not given, you can identify which equation that you need to use. I will tell how to use it. An automobile starts at rest, which means initial velocity 0. Whenever you read, write like this. Okay, initial velocity 0 and accelerates at 3.5 meter per second squared, acceleration 3.5 meter per second squared. If you understand the question is from the equation of motion, first you write these 5 ingredients. Then you start reading the question. After a traffic light turns green, okay, how far will it have gone? How far? Distance, right? So you need to calculate the distance traveled. How far will it have gone when it is traveling at 25 meter per second? When it is traveling at 25 meter per second. In this question, there is no information about time, means time is not given in this question. Time is not given. If time is not given, out of these 3 equations, which equation will you use? The equation in that time is not given. So you will use the third equation, right? You will be using the third equation, that is final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied displacement. What is the value of the final velocity? Final velocity is 25, so 25 squared, that is equal to initial velocity 0, 0 squared is 0 plus 2 multiplied acceleration multiplied delta x, 2 multiplied, what's the value of acceleration? 3.5 multiplied delta x. What do you need to calculate? You need to calculate how far distance traveled, right? Means you need to calculate the delta x. Rewrite that equation for delta x. So delta x, that is equal to 25 squared divided by 2 multiplied 3.5. 25 squared, that is 625, right? Just use the calculator, okay? 2 into 3.5 is 7. So 25 squared 625, correct, right? Okay, divided by 7, that is 89.3 meter it traveled. 89.3 meters is the distance traveled. Okay, now you got the answer, right? Now we will do the next question. Okay, example 5. See, I am keeping these 5 data and the equation here because we need to use the same thing, right? For the next question also. You are driving a car. What are you doing? You are driving a car traveling at a constant velocity of 25 meter per second. So you are traveling at a constant velocity of 25 meter per second. You are traveling with that velocity, that is your initial velocity along a straight road. When you see a child suddenly run onto the road, it takes 0.45 second. For you it takes 0.45 second. For what? To react and apply the brakes. As a result, the car slows with a steady acceleration of 8.5 meter per second squared. So car is slowing down, so acceleration will be negative 8.5 meter per second squared. As a result, the car slows here in a direction opposite your motion and come to a stop. What is the displacement of the car before it stops? You are driving a car traveling at a constant velocity of 25 meter per second along a straight road. When you see the child suddenly run onto the road, it takes 0.45 seconds for you to react and apply the brake. As a result, the car slows with a steady acceleration of 8.5 meter per second squared in a direction opposite to your motion and come to a stop. So final velocity is 0 because it come to a stop. What is the total displacement of the car before it stops? You need to calculate the displacement of the car. So here is time given or not? In this question, there is a trap in this question. So here the time given is the reaction time. Means you see the boy crossing the road, then you are applying the brake. So it is the time between. It is a time between when you see the boy and apply the brake. That is your reaction time. But this here, this is not the time we need. We need the time between after you apply the brake and the car stop. When you apply the brake, suddenly the car will not stop, right? The car will move a distance and it will stop. It will gradually stop. So you need that time. You need the time between when you apply the brake and the car stop. That time duration you need. That time is not given in the question. So this question, there is a trick, a trap here. So time is not given. Time is not given. So which equation will you use? You will use the equation in the time is not given. So you will use equation number 3. Final velocity squared. Same type of question, right? Again we need to calculate the displacement. You can do your own. Initial velocity squared plus 2 multiplied acceleration multiplied delta x. So final velocity here it is 0. 0 squared is 0. That is equal to initial velocity 25 squared is 625 plus 2 multiplied acceleration is negative 8.5 multiplied delta x. We need to calculate the delta x. So delta x, distance traveled, that is equal to, when it comes to this side, it becomes negative 625 divided by 2 multiplied negative 8.5. So negative 8.5, right? We will check. 625 negative 625 divided by 2 multiplied negative 8.5, 36.76. So we will write 36.8. okay, 36.8 meter is the distance traveled after you apply the brake until it stops.